Hello everyone, welcome to my channel. I will teach you today the chapter Chemical Changes and Reactions. This is a very broad chapter. Starting from class 7 till class 12, we have got a number of reactions, number of changes. I have tried to limit the topic and start with the very basic concept. First, the characteristics of chemical reaction. Okay, so any chemical reaction basically means two components A and B will combine and give you a third component, or maybe more than two components can also combine together to give you a third component. This doesn't mean only one product, it can be more than one product, P, Q, R and so on. So this is what a chemical reaction is. Now there are some basic characteristics which are followed in general. Change of color. There are few reactions where change of color is highly visible. In this case, basically I'm trying to explain how will you understand a reaction has taken place. There will either be change in color or some change of state or anything, any indication which will help you understand. Change in color is seen, suppose for example I consider Fe plus CuSO4. If you know, CuSO4 is a blue colored solution, blue solution. Copper sulfate is blue colored. The reaction will give FeSO4 plus Cu. This is a green colored solution. So first characteristic is a blue color compound is getting converted into green. You can easily understand that a reaction has taken place. Okay. Next, evolution of gas. Okay. Suppose I consider a reaction, say for example AgNO3. Okay, no, formation of evolution of gas, right? Okay, evolution of gas. Okay, let's consider PbNO3 whole 2. Okay, this on heating will form PbO plus NO2 plus O2. NO2 is a gas, O2 is also a gas. This gas is colored. This gas is colorless. However, it has got some other characteristics. We can test that this gas is brown colored gas. That is another characteristic of this reaction. Formation of precipitate. Yeah, this one I was saying. AgNO3 plus NaCl. Reaction will give you product AgCl plus NaNO3. This compound is white in color. White precipitate. Now see, these are very complicated if you don't know the color. Throughout the course, when you are reading from class 7 till class 12, you will come to know about a number of reactions. In every single case, a new compound will arise. During that time, you have to keep these colors, precipitate, solution, colored gases, all these needs to be there in your mind. These are basically, you can say, you have to learn them. No other way out. Like AgCl is always white in color. Copper sulfate is always blue in color. So whenever you are seeing these compounds, be careful that this color is this. I know the color. I know the color change. That's it. This is how we adapt things. No other way out. Last is change of state. Very common example is NH3 plus HCl combines to form NH4Cl. So two gaseous compound combines to form a solid compound. Okay. Here I can also mention that this is yellow colored. Okay. Lead oxide is yellow in color. So from here only blue colored solution is copper sulfate. Yellow colored compound is lead oxide. NO2 is a brown colored gas. O2 is colorless. O2, CO2, all these are colorless. AgCl is white precipitate. Okay. And NH3 ammonia. HCl is a gas, hydrogen chloride, which when comes in contact with water becomes acid, hydrochloric acid. So this is, in this case, it's a gas. Be careful. Hydrogen chloride only when comes in contact with moisture becomes acid. NH4Cl, that is a solid compound. Okay. So these are the basic characteristics through which you should come to know about the color changes, the compounds that are formed. That's it. When you are aware of these, you will easily understand the characteristics taking place. Okay. Now, what do you mean by a catalyst? See, it's written only a substance that alters the rate of reaction without itself taking part in the reaction. See. This is basically going to act as a enhancer of the reaction. We add something in a reaction medium to increase the rate. Suppose A plus B gives product P in 10 minutes. I need the product in 5 minutes. If there is some way out, is there any way out? Yes. In this case, I need a catalyst, influencer or enhancer. Now, is it always positive? Always the time is going to increase? No. There are times when the product will be obtained in 15 minutes. So, based on that, we can differentiate it into positive catalyst and negative catalyst. Accelerating the rate of the reaction is a positive one. Retarding the rate of reaction is a negative catalyst. So, this is also important. For example, positive catalyst. A positive catalyst example is iron. Okay, iron in reaction N2 plus H2, 3H2, giving ammonia. Haber's process, famous reaction in which ammonia is synthesized. In this case, iron is the catalyst. Okay, it is going to increase the rate of the reaction. However, there is a negative catalyst. There are negative catalysts as well. For example, H3PO4. H3PO4, phosphoric acid, retards the rate of reaction. H2O2, hydrogen peroxide, when decomposes to form H2 and O2, in that case, this will act as a negative catalyst. Also, alcohol, ethyl alcohol, also decreases the rate of reaction. So, these are two examples. Just remember the name of example. A negative catalyst is not that common. We require them only when we don't want the product to be, the reaction to go very fast. We need to slow it down. Then only this take place. Otherwise, positive catalyst is the one which is mainly used. Last is promoter. Substances that influence the rate of a chemical reaction by improving the efficiency of the catalyst. Now, catalyst also need to get influenced at times. In that case, we need a promoter. Common example of promoter is molybdenum. In the same reaction I have shown, in this Haber's process only, the reaction, the promoter is molybdenum metal. Okay, that's it. So one example and definition is enough. Types of chemical changes. Now I was simply writing down the reaction. I have shown some examples. I have shown the color change. However, if you don't know how to write down the reaction, then it's a problem. There are types of chemical reaction. First is direct combination or synthesis reaction. Synthesis, in which A combines with B to form AB directly. You can directly see two compounds combining to form the third product. This is known as direct combination reaction. Okay. For example, very easy reaction, H2 plus Cl2 combines to form HCl. Okay. In presence of sunlight, it will combine to form HCl. It is an example of synthesis reaction. A plus B combining to form AB. Okay. H2 plus O2, H2 plus O2, H2O. So easily, whenever you are seeing two compounds combining to form the third one, it's a direct combination. Correct. Decomposition. Decomposition is exactly opposite to that of combination reaction. AB breaks to form A plus B. AB, A plus B. That's it. Exactly the opposite reaction. Example, CaCO3, in which CaO plus CO2. These two are formed from this. So, direct breaking of one compound into two. Next, displacement reaction. Okay, displacement means, or single displacement you can say. Single displacement. Same thing. Single displacement. What happens in this case? A plus BC combines to form AC plus B. What happens? One is coming and taking this place and the other remains as it is. For example, Fe plus CuSO4. Just now I gave you the example of this compound. What is the way or mode of writing this? Simple displacement. Fe combines with the negative part and the metal remains as it is. So the color change is also being shown. Blue to green. Clear? Double displacement or double decomposition we also see at times. AgNO3. Just now I have given this example as well. NaCl combines to form AgCl. How to write the product? See, I can easily write down the product from the reactants. So we don't need to learn everything. There is chemistry as well. Not chemistry, just simply displacing them. That's it. AgCl, it's a white colored compound. NaNO3 is not colored. Okay, that's it. Types of chemical reaction. Now, I'll be giving you a series of compounds, a series of metals first, and based on that, what product they can form, from which you will get a basic idea of the products or the compounds which can break to give you certain amount of gases or compounds or hydroxides, anything. See, hydroxide when broken, metal hydroxides. Now I have shown a series of compounds over here, a series of metals over here. See, this is the general representation of the metal activity series. Metal activity series. What basically this series indicates? The reactivity of each metal down the group when we are moving from top to bottom of the series. The reactivity of this series decreases. So what is happening in this case? The reactivity decreases, means the most reactive metal in the series is sodium and the least reactive is silver. See, that's the reason we can wear silver metal. Many people wear silver jewelries because it is not reactive. It will not easily react. Okay, gold, platinum, those are even less reactive. Okay, first, so I am considering, suppose metal hydroxide, means KOH, NaOH. What will happen when I am heating these compounds? What will happen when they dissociate? They are very stable to heat, no reaction. Very stable. So these are highly reactive, but they're stable to heat. They are going to form nothing. They're already stable. They are reactive. So potassium will react to form KOH. Na will react to form NaOH. Na will form a sodium oxide. Sodium oxide in presence of water will give NaOH and a hydrogen. K2O in presence of water will give KOH and hydrogen. Now they have become stable. They are reactive, means their compounds are stable. But they are reactive. They will undergo reaction fast. The metals are reactive. So the metal hydroxides are stable. Okay. So they will not undergo any reaction. Next, this series, calcium, magnesium, aluminum, zinc, iron, lead, copper, in this case, they are going to decompose because they are comparatively less reactive. Okay. So their compounds, that is calcium hydroxide, magnesium hydroxide, aluminum hydroxide, zinc hydroxide, the same thing will happen. I'm not writing all of them. So the product in this case will be metal oxide, that is calcium oxide and water, magnesium oxide and water. Okay, same for all of them, zinc oxide and water. Okay, zinc oxide is yellow colored compound. Calcium oxide, it is white colored compound. Okay, lead oxide in this case will be formed. Lead oxide is also, this is actually yellow when hot. Zinc oxide is yellow when hot and white when cold. So these are the informations that you're supposed to have. Lead oxide is yellow in color only, yellow colored oxide plus water. Okay, and copper hydroxide is CuO. CuO is a black colored oxide. So black oxide. So this is important. You have to be aware of the color, because whenever a particular reaction is given, you don't know what is the product actually because you don't know the color. So black colored compound is copper oxide and water. Done. The last part is metal hydroxide. In this case, they are so very much less reactive that they will easily break to form, like the compounds are less reactive, so they will easily break. These are not stable oxides. HgOH, AgOH, these are not stable. So what will they do? They will easily break to form corresponding metal and oxygen and water. See, be very careful. So what is happening? No reaction in this case. In this case, no reaction. Just a second. Just to separate or highlight these points. No reaction in metal hydroxides like sodium and potassium. So sodium and potassium are very reactive. No problem in this case to form hydroxides. See, this point is important. They are reactive. Why they are not breaking? They will not break because these are stable. Sodium and potassium is not stable. Their hydroxide is stable. Whenever you are reactive, you are going to form something. The formed product is stable, no? They are not going to undergo reaction, so they will not break. So these are stable to heat. They will not break. They are comparatively less. So if you're giving heat to them, they will feel like, okay, let's form something. They have got corresponding colors. These are not that colorful. These are yellow when hot, white when cold. Next, this is a yellow colored compound. That's it. Last is metal. Metal is formed when AgOH or HgOH is being heated. Same in this case, metal carbonate, the metal activity series written at first. Now these two compounds are again the same concept. They are also stable to heat. They will not form anything. In this case also, K2CO3, Na2CO3. Stable to heat will form nothing, no reaction. Now let's come to this series. CaCO3. I have written also in the first case. Calcium oxide and CO2. Same in all the cases. MgO, CO2. So which gas is being released? Question may come. Which gas is released when these carbonates are heated? CO2. What is the characteristic property of CO2? Effervescence. Effervescence. If you don't know what is effervescence, I have actually shown, or I have said earlier also in some video. Effervescence is basically bubble formation. Bubble formation in the reaction medium. Whenever, see, also CO2 turns lime water milky. Turns lime water milky. Lime water is CaOH whole 2. CaOH whole 2 milky. Okay. Lime water is CaOH whole 2. When it reacts with CO2, it will give a milky compound CO2 to form CaCO3, calcium carbonate, which is limestone or chalk or marble. This is what gives marble the white color. Okay. Anyway, that's a different concept, but the characteristic property needs to be known. They can ask you what gas is formed. Give one test for the gas. How will you understand this gas is formed? Because of the effervescence. Because of the various effervescence that it shows, it is going to be CO2. Okay. All of these same thing. Color also remains the same. The oxide is only formed. The same thing is only getting formed. Last is Ag2CO3 or Ag2. This one will be Ag2CO3. What will happen on being heated? Metal again. Metal plus O2 plus CO2. Now if they ask, name one metal carbonate which will release oxygen gas. In none of these cases oxygen will be formed except in case of silver carbonate. So oxygen is released only in case of Ag or Ag2CO3. Done. Last is the metal nitrate. Same, the series again. Now KNO3 or NNO3, KNO3 or NNO3, when it is heated, now they will break. They will break. However, very strong heat needs to be given. They will form corresponding metal nitrate, MNO2. And this is the indication of that it's a metal, plus NO2. Either sodium or potassium. Both cases, same thing will form. Oxygen gas is formed. Okay. Rest all of these. CaNO3 whole 2. NO3 whole 2 will form CaO plus NO2 plus O2. If you have noticed carefully in the first page, in the first portion of this video, I have shown PbNO3 whole 2 is going to release NO2 gas and O2 gas. The same is applicable for the rest of the oxides as well, rest of the nitrates. So this is brown colored gas. Brown colored gas. However, oxygen is colorless. Okay, done. AgNO3, in this case, AgNO3, this when heated will form corresponding metal Ag plus NO2 plus O2. So again oxygen is formed. So metal and oxygen formed in case of AgNO3, and in case of KNO3 and NO3, metal nitrite and oxygen is formed. So this is the difference between these two. Okay, so lot of reactions. Now let's check some questions which may come from this part. Metal nitrates. Name two metal nitrates which do not produce NO2. This will be 2 below. Okay. Do not produce NO2 on heating. Do not produce NO2 on heating. You cannot write AgNO3 as the answer. CNO2 is formed. So your answer will be KNO3, sodium nitrate or potassium nitrate. Name the gas evolved when zinc carbonate is heated. Carbonate, carbon dioxide, CO2. Very easy. Two metal carbonates which produce metal on heating. So metal carbonates producing metal on heating. Metal is always the last part. See, metal is only the last part. Ag. That's it. The answer here will be, in this case, Ag. Okay. Metal carbonate, Ag2CO3 or Ag2CO3, same thing. Metal hydroxides which are stable to heat, same, NaOH and KOH. Stable to heat means whatever you do, they will not form anything. Name two metal nitrates which produce only oxygen gas on heating. Only oxygen gas on heating. So you cannot write NO2. You cannot write AgNO3 because NO2 is also formed. So answer will be KNO3 and NO3. Only oxygen. Two metal carbonates stable to heat, same question have repeated, I guess. So metal carbonate stable to heat will be Na2CO3. No, yeah, this I said only. Na2CO3, K2CO3. Next, state your observation when lead nitrate is heated. Observation is yellow colored oxide. Okay, the answer will be PbO plus NO2 plus O2. And your observation will be yellow oxide, reddish brown gas, and a colorless gas O2 is formed. Okay, so this is your observation. In case of observation, you have to write the equation. If you're writing the equation, that's well and good, but if you're not mentioning the color, then marks will be deducted. Observation means what you're seeing for real. It's not the equation you're carrying out. No, your observation, what you are noticing. Okay, two gases which combine to form a solid, NH3 gas, HCl gas. Two solids which combine to form a liquid, carbon and sulfur, combine to form CS2, that's a liquid. Also, if they ask two liquids which combine to, two gases which combines to form a liquid. Very easy. Please try this question, whoever is watching the video. Two gases which combines to form a liquid. This is the easiest question ever. What happens when ferrous sulfate is added to sodium hydroxide solution? Okay, so FeSO4 reacts with NaOH to form FeOH whole 2 plus Na2SO4. This is a dirty green precipitate. Dirty green precipitate. FeOH whole 2 is a dirty green compound. Okay. That is it for this video. I'll also list some more such reaction in which you will be coming to know about the color, your observation, what is the variation of state that may happen in a reaction. Also, a few more information about this chemical reaction thing. Okay, that is it for this video. I hope you like this video. Thanks for watching.